Welcome to the presentation. My name is Andy Dowling. I am the founder and CEO of Digitary. This is a rerun of a presentation I gave in April 2019 at the Huntington Declaration Network in Puebla, Mexico. Despite the controversial title, really this is not a dig at blockchain, but more of a mature, considered conversation to look at what problem and what benefits blockchain actually brings to the digital credentialing space. Truth be told, I'm a tech guy by background. I build secure systems and cryptographic based systems. So, the idea of blockchain technology appeals to my technical nature. I like it. It's pretty cool. But at the end of the day, I'm also a business leader, and therefore I have to think of, well, what blockchain does, or what problem does blockchain actually solve that hasn't been solved by technologies that we're already using? And I guess that's where the confusion creeps in for me and for a number of other people. We embarked on a bit of a journey about 12 months or so ago, where we engaged some blockchain consultants and we actually started to look at this problem to try and understand what exactly blockchain brings, what are the risks, what are the costs, what are the benefits of blockchain, and the implications really for the three main actors involved in the credentialing ecosystem. And that's namely the issuer of a credential, school, college, university, or so on, the learner themselves, and a third party who needs to verify those credentials. So what's the impact that blockchain actually has? And it's really important because at the end of the day, blockchain is just a technology, just like any other technology that comes and goes. And if you're thinking about building a system, you really need to think about solving the problem first and then applying the technology, rather than building a solution based on a particular technology. So it's important that we get things the right way around. And bear in mind, there's an awful lot of hype around blockchain at the moment, and not just cryptocurrency hype, but actual hype around what the technology can and can't do. And there is that sense that blockchain is this giant hammer and every problem domain out there is a nail. And not everything out there is going to be solved by or improved by implementing a blockchain version of it. So really, that hype is, I suppose, it is good and bad in a sense. The good side of having hype like that is that there's a bit more focus on digital credentialing. There's more funding, there's more opportunities, and more attention, which is great. The negative, of course, is that it's sometimes hard to see the wood from the trees, particularly because the technology itself is fairly complicated in places as well. So what I'm going to do, and I've probably spent a lot more time on this than I should have, is take a little bit of a semi-technical dive and walk through what the impact of blockchain is from each of the three actors, the learner, the issuer, and the third-party verifier as well. And yeah, look, my message really is, it is important to think things through before you make a decision. And look, we've seen in situations of Brexit in the EU and the UK and so on, where an awful lot of people just blindly went in and voted for something because everybody else was. And now they're finding out that what's probably wasn't necessarily the best idea, and they're having a rethink about that. So it's important to understand the implications of your decision as early as possible in the decision-making process. So this is Digitary's logo. It's not a plug showing you that logo, but what's important about it is the triangle in the middle. This is the same logo we've had for the past 14, 15 years, bar the odd facelift every now and then. But the triangle has some meaning. The triangle represents, in a technology-agnostic way, the three main parties who are served by a digital credentialing ecosystem: the issuer of the credential, the learner, and the verifier. And when you think about it, there's almost, for the purposes of this presentation anyway, two ways in which you can break down the types of approaches to the verification, say, of digital credentialing. And there's a reason I'm focusing here on the verification, and particularly in the context of a shift towards learner-centric credentialing, which we have implemented at Digitary for the past 14 odd years, is you can't do that at the expense of the verifier. The verifier is really important, as are all actors in this ecosystem. If the verifier cannot easily verify a digital credential, they're going to go back to what they already know, which is paper, which is bad. Okay, so it's important that we get a good balance between all three actors in the ecosystem. So of those two methods, the first one is a really simple traditional method, which is what we call hosted service. The verifier makes an inquiry, the learner provides their consent, and they make that inquiry to the issuer. And the issuer really simply does all the heavy lifting and gives the verifier an answer. Yes, a credential is valid or not. And they answer all of the questions. Was it valid at the time it was issued? Has it been revoked? Has it expired? Does it belong to the learner? All of these things can be answered in a very accessible format for the verifier. And that's why most credential evaluators and employers and background checkers will always insist on going back to source. And this applies whether or not it's an exchange network you're using or you're going back to the issuer's website. But it's really accessible, and the only thing you need to know from a verification point of view is, am I talking to the right place, the source of authority, source of authority on that particular record. Another approach, which is aligned to blockchain and also things like certified PDF, is what we call the bearer instrument. And the whole idea here is, rather than the issuer providing a verification service, the issuer issues a cryptographically signed bearer instrument and gives that to the learner. And then the learner can share that with whoever they want, whenever they want. Now, this is all very well and good, but what it does do is it rebalances the responsibility in the ecosystem. So basically, the learner and the verifier have to do more in this situation. It's not the issuer doing all the heavy lifting, and therefore the engineering behind that is a bit more complex. So in the case of a blockchain situation, what happens is this. Typically, an issuer will create a hash of the record, anchor that hash onto a particular blockchain, and we'll get into the details of that in a second, and they make the certified record available to the learner as a file. The learner can then share it with the verifier as they see fit, and the issuer doesn't have to get involved. So from a privacy point of view, that's good. And then the verifier, to verify it, well, they need to check the blockchain. They also need to check the record and interrogate that in order to get their answer. So they have to look in two places. So it's a little bit more complicated. And in fact, as you'll see in a minute, it's actually more complicated because if it's anchored to the public blockchain can't actually tell you who issued a record, which is kind of a problem when it comes to digital credentialing. It's fine in a digital cache environment, which is anonymous or pseudonymous by design, but in a credentialing environment, it's a little bit trickier than that. In order to independently verify a record using blockchain technology, you need three things. The first thing is you need to make sure that the learner has a copy, and so they need to be a responsible custodian of the record. The second thing is that the blockchain on which the record was anchored needs to be accessible at the time of verification. That's really important because it calls into question the sustainability of particular blockchain infrastructures. For example, you've got three main types. The first type is public, second is permissioned, and the third type is what you call private. Public blockchains are like Ethereum, Bitcoin, and so on and so forth. And you've got to remember that their security and sustainability and viability is really tied to the economics of mining coins. And so some institutions may not necessarily want to take the risk that the economics of those blockchains collapse at some point down the road, and the ability to verify records is gone. And so in that case, they employ permissioned blockchains where they actually have to maintain their own infrastructure as part of a consortium and have appropriate governance and so on around that. Private blockchains are kind of pointless in this situation because the whole idea is that the blockchain infrastructure is accessible independently of the issuer. If it's a private blockchain that the issuer has, as soon as the issuer disappears or goes out of business, that blockchain disappears. So really, for the purposes of credentialing, public and permission blockchains are the most suitable candidates we feel. The third thing that you need is extended issuer validation data. So for example, to understand above and beyond what's actually being put on the blockchain, what extra information do you need to verify a credential? For example, what keys were used by the issuer to issue a credential on the blockchain, cryptographic keys? Where is the revocation list stored to say what credentials have been revoked? Where is that stored? Is it stored on a blockchain? Is it stored in a repository? All of these three elements, you actually need them to be available independently of the issuer. So with that in mind, I mean, that sounds like a really complicated way to verify credentials, and why would you actually bother doing that when if you can go back to source, it is much, much simpler? Well, there's a number of reasons why you might want to do this. Firstly is what you'd call issuer de-risking, which is basically reducing the risk of IT compromise from the school's point of view, so that because they don't have to host the records, they give them to the learners instead. The second one is portability, so that the learner can share their record without the issuer having to get involved because they have their own copy. The third is privacy. The learner can have more private transactions with prospective employers and so on without the issuer getting involved, because they can store, share and verify the credential without the issuer's involvement. And number four is this ability to independently verify the record if the issuer or their vendor was no longer available, by using this issuer independent technical infrastructure that is the blockchain. Now, these are all very valid reasons for employing blockchain, but an interesting point is you actually don't need blockchain for any of these. You can achieve all of this by just simply issuing certified PDF documents. What blockchain does give you is this concept of what you call proof of ownership. And ownership in some circles is a bit of a dirty word, particularly when institutions sort of co-own in a certain sense the record as well as the learner, depending on who you ask. It's a hot topic, that one. But what it means is that the learner has the ability to digitally prove that the record or the credential was issued to them because they have the corresponding cryptographic key. And this is technology that's been around for the past 25, 30 years. It's nothing new, but it's an additional value add that you can bring with blockchain. So let's look at it from the issuer's perspective. What does all of this mean for the issuer if they go down the blockchain route? And to explore that a little bit, what we do is we look at, regardless of what technology you employ, what does an issuer have to do by way of credentialing? When you think about it, your typical school will have to deal with the ordering of credentials, maybe from students or graduates who haven't yet been provisioned with digital ones. They need to fulfill them. They need to extract them from their student system, and they need to take care of the issuing of those credentials. Again, this applies regardless of whether or not you're using blockchain. Then there's what you call lifecycle management. And lifecycle management is what happens after the credential has been issued. If it needs to be revoked, if it needs to be replaced, if the school needs to report perhaps to an authority on credentials that they've issued. For those reasons, the issuer needs to be able to store a copy of the credential. And in a paper I published last year on the topic, one of the central premise of the paper was this notion that there was an awful lot of talk last year about the idea of blockchain being this silver bullet where you could anchor a credential to the blockchain, give a copy to the learner, and the issuing institution or school did not have to keep the record anymore. And that just breaks down completely, because they do have to keep the record. Similarly, when a record has been issued, there are a number of credentialing elements that can be taken care of by the issuing institution as well. So sharing and verification are two services that are typically provided. So in the North American context, when you have point-to-point networks, you see that institutions are typically still involved in the sharing/delivery of credentials, because an institution A may request a transcript from institution B, and therefore institution B needs to be able to fulfill that and deliver that request across maybe a trusted network. And verification is part and parcel of that, perhaps by providing a verification service as well. What we do at Digitary is we provide a system that is hosted at the issuer's institution, almost like that trusted service model that we spoke about earlier. And it enables the learner to control the sharing process, but that the record is still hosted at the issuer. So what that does is that offloads the verification to the system and the sharing to the learner the way it should be. And it also makes it very, very accessible, because from a third party or verifier's point of view, they're actually verifying credentials back at source, back at the issuing institution. So the trust model is exactly what they would expect to see. Blockchain takes it a step further, and it tries to eliminate the sharing and verification altogether from the issuing institution. The side effect of doing that is that, because this doesn't come for free, The side effect for the institution is they now need to be able to manage blockchain infrastructure if they're using a permissioned um, blockchain, and the associated technical infrastructure and governance and maintenance that comes with that, and that doesn't come for free. They also need to be mindful of how do they provide independent verification artifacts in a standards compliant way so that if that institution was ever to go out of business, that those records could be independently verified by a third party. And these are standards that we haven't really even embraced yet. Okay. And then the third aspect, of course, is the blockchain monitoring, and that's particularly important in the context of public blockchains because the institution no longer controls the infrastructure. So how do they know that their key hasn't been compromised and is being used to issue credentials on the blockchain? So there's the additional monitoring capability that they need to put in place as well. And it's a little bit more complex when you don't control the infrastructure yourself. So the point here is it doesn't come for free. So 3 key takeaways from the issuer's perspective: they need to keep records, they need supporting IT systems to issue credentials on the blockchain regardless, and independent verification. There's a call for the need for standards in order for blockchain to fulfill its promise in this regard. So let's move across to the learner. From the learner's perspective, the big benefit they get from having a file which can be independently shared and verified is portability. No question, it is by far the biggest benefit. They can share it with whoever they like, the issuer doesn't know, they have more options to share a record by uploading to forms and sending by email and so on and so forth. But what's really key to making this happen is standardization around the content of those credentials and the verification of them. Because if every different issuer starts adopting and implementing blockchain in a different way, then how are verifiers to know which way to verify these different credentials? So portability, the key to portability is verification and standardization of verification and content. But really platforms get to benefit greatly when that standardization is in place, because from a learner's point of view, I can easily take my verified credentials. If they're standards compliant, I can pop them into an e-portfolio, upload them into a job seeking application and so on, and consolidate my credentials from different places. So there's a big bright future for blockchain in this context, but it needs an awful lot of work and standardization before we can start to realize those benefits. The other aspect as well is this idea of learner identity and ownership. And what this means is in a traditional hosted environment where a learner logs into a system and accesses their credentials, it's the typical login method. I go in and put in my username and password, and what's going to happen? If I don't remember my password, well, there's a bit of forgiveness there because I can go in, I can put in my email and I can reset my password. And this is a well-trodden path that users have experienced over the years. And let's be honest, users aren't necessarily going to be accessing their credentials very frequently. So the likelihood of forgotten passwords is probably increased in this case. If you look at blockchain and the way in which it uses cryptographic keys, it expects learners to keep their credentials and their keys in a secure cryptographic wallet, which is great from a privacy perspective, but the reality is that those students and graduates are more likely to lose and forget their passwords, and once they have a crypto wallet, there is no recovery. It is very, very difficult. If you forget your password, you're kind of screwed. So what that means is that they end up going back to the issuer to get their credentials reissued to a new crypto identity. And really, if that starts happening at scale, the issuer has really replaced one problem with another. That is, instead of issuing credentials on paper, they're issuing them digitally, but they keep reissuing them because the learner keeps forgetting their passwords to their crypto wallets. So what is needed to make this happen is a scenario where the crypto keys that are used for someone's wallet are the same crypto keys that users use every day when they pick up their phone and they put in their Face ID or their thumbprint or whatever to unlock their phone and get access to their day-to-day government services or whatever they need. It's really that single identity with a key management framework around it, which may well be a self-sovereign identity. But again, the point is we are quite a way away from that yet. So from a portability and a privacy perspective, blockchain can be very useful, but the identity piece needs quite a lot of work, and there's some standardization to be done in that space. Moving across finally to the verifiers perspective. And the verifier is a crucial actor in the ecosystem here, because at the end of the day, if they cannot verify a digital credential easily, it doesn't really have much value for the learner, and the verifier is going to go back to what they know, which is looking for paper, which the learner then has to chase up, and there's a manual process involved. So it's important that verifiers can actually use these digital credentials. This slide here sort of looks at the main questions that a verifier will actually ask when they want to verify a credential. And it's, do I have consent of the learner? Who issued it? Was it modified? When was it issued? Was it revoked? Was it issued to the learner? And if you actually look at the trusted service, which is the column on the very right, it answers all of these questions. However, when you start looking at things like certified PDF, which is the first column, it answers most of the questions, but in order to determine revocation status, you end up going back to the issuer using proprietary extensions. With blockchain doesn't actually identify who issued a record, so you end up going back to the issuer anyway. So the point being is that when you're dealing with these bearer instruments, verification is actually quite complicated, and you have to look for verification answers in a number of different places. This is fine if you're building a system or a platform and you have standards. However, if you have the casual verifier who's just picked up a file from a learner, it's a lot more challenging. So looking at the individual verifiers, at the end of the day, someone who's maybe a small employer who's received a record from a student that they need to verify, they just want the answer, simple answer. Is this valid or not? And can I get the answer from a trusted source? And as we know, blockchain verification is complex because you've got to look in multiple places. And the easy solution, as you can see in some of the early blockchain implementations, is to provide an online verification service where you may upload an XML or a JSON file or a PDF file or whatever to a site which will give you a verification answer. And on the surface, that sounds really simple, but at the end of the day, you've got to ask, well, who hosts that service? If that service is hosted by the issuer of the credential, it sort of defeats the purpose for blockchain, because blockchain is intended to make these transactions more private. And so what you're doing is you're enabling the issuer to actually track those verifications, and you sort of wonder, well, why did we do blockchain in the first place? If that service is maybe hosted by a third party, let's say a higher level organization, the Ministry of Education or so on, in case the issuer goes out of business, then that actually creates an even bigger privacy issue, because now you have a situation where there's a site at a national level where people are uploading personally identifiable information by way of digital credentials so they can be verified. And that third party can scrape and monitor and track and do all of those things. So there are some challenges here. And it's almost you solve one problem and you create a number of other problems with blockchain. And these things need to be thought out. So there's more work to be done in this space. Platform verification, as we know, is probably where the benefit really is here for blockchain, because large systems, the LinkedIns of this world and the various job sites and social networks and so on, they have teams who can build APIs to hook into blockchains and interrogate blockchains and parse digital credentials and piece the whole picture together to get a verification response or a verification answer, and to present that in a particular way. But the key to doing all of this is standardization again. And remember, while we're at sort of the early days of the adoption cycle of blockchain, we're really innovating in this space, and we have a number of open source solutions. Open source and open standards are not the same thing. Open source, of course, is freely accessible source code which can be used to implement systems, whereas open standards are specifications that have been through a standardization and ratification process that have been widely accepted by a trusted and recognized community. So really what I would say is the strength of, from a verification point of view, is really in the platform verification, with the caveat that standards need to be implemented for this to work at scale in the long term. Whereas for individual verification, there is a question mark over what blockchain actually brings here. So in theory, earlier on we sort of presented what were the main benefits of blockchain. And in theory, issuer de-risking, in the sense that issuers can reduce their risk of being compromised by hosting these records, but at the end of the day, they still have to keep the learner's records anyway, so that is questionable. Portability, without question, is a big benefit of using bearer instruments or blockchain anchored records, but provided the appropriate standards are in place. Yes, sharing is definitely more private. However, for individual verifications, those privacy risks are kicked down the road to the verification point, where they could potentially upload PII to a site which is scraping or tracking that, or even a site that's just pretending to be a legitimate verifier as well. The independent verification is really a case of there's a mind shift needed here at that, because at source verification is really popular, and we need more work on the standardization of that verification for it to work. And again, the proof of ownership aspect of blockchain, which is attractive, but for that to work seamlessly, we really need sort of scaled adoption of be it self-sovereign or other cryptographic digital IDs, and for services to start relying and using on those IDs for verification. So we've got some time here to get this right. So in the context of what opportunities blockchain brings, I suppose from the three perspectives, we see that there's some work to be done around the blockchain sustainability piece from the issuer's perspective, because it's a critical part of their infrastructure, and also for them to be able to provide standards compliant artifacts to assist with the independent verification of blockchain anchored records. Secondly, there's also the mind shift for learners to become custodians of their own records, because remember that we have sort of gotten used to somebody else looking after our files for us. We store them in the cloud. If we forget passwords, we go to password reset. And so the blockchain paradigm shifts that responsibility down to the learner. And as well as the mind shift, there also needs to be a technology shift around learner identity at scale. And also from the verifier's point of view, it's the independent verification standards as well. So that's really it. If you have any questions on the presentation, I'm happy to take them. Best way to contact me is pop me an email, andy.dowling@digitary.net. I'm usually currently GMT +9 is the time zone that I'm in. So feel free to pop me an email and I will be delighted to get back to you. Thanks very much for listening. Much appreciated. All the best. Bye-bye.